modulating signal. And here the final output can be obtained. Final output can be obtained. Okay. Now, what are the different types of input signals? What are the different types of signals that can be transmitted? Types of signals that can be transmitted. Okay. So first one is voice signal. Voice signal. Second is audio signal. Audio signal. Third one is video signal. And the fourth type of signal is data signal. Fourth type is data signal. Okay. So voice signal means in the lab session I was telling you whatever the maximum voice possible. Okay. It is to the maximum of 3.5 kilohertz frequency. It may be 0 to 3.5, but less than 300, the voice is very small. We will not be able to hear. So at least 300 is an audible or the amount what we can able to hear. So 300 to 3.5 kilohertz, this is the range of voice signal, range of human voice signal. Next, audio signal, using loudspeaker and all, we can increase the frequency. Audio signal is 20 hertz to 20 kilohertz is the range of frequency of audio signal. 20 hertz to 20 kilohertz is the frequency of audio signal. Okay. Next, video signal. Video signal, it is in the range of 0 to 4.5 megahertz. 0 to 4.5 megahertz. This is the frequency of video signal. Now, data signal means it can be ones and zeros representation, binary data signal. Okay, binary data, ones and zeros can be used. Ones and zeros can be used to represent the signal. And this data signal can be done for voice, audio, or video signals. Okay, it can be voice signal, audio signal, or video signal, but in the representation of ones and zeros. Okay, this is about the different types of signals available. These are the different types of signals available. Now coming to the channel, what are the types of channel? What are the types of channel? So we have different types. One is twisted pair channel. Second one is coaxial cable. Third one is fiber optic channel, fiber optic. And last one is free space. These are different types of channels. Okay, one is twisted pair. Second one is coaxial cable, fiber optic, then free space. Free space means we know in mobile when we talk, the signal travels in free space. And in cable TV and all, we will be using coaxial. Coaxial cable is used in the cable TV purpose, like that. We will use coaxial cable. And then fiber optic will have less amount of losses. Signal in the channel while traveling, less minimum loss will happen when fiber optic is used. Twisted pair means cable itself will be twisted in electrical department, something high current, etc., to be transmitted. Okay, something like that. They may be using, sometimes you might have seen the diagrams or pictures of this twisted cable. And here more losses will take place. Because the cable itself is twisted type. Okay, there is possibility of losses. And free space generally we know. These are the types of channels available. Okay. Now, next is what we will do with the transmitter and receiver. What we are going to do with the transmitter and receiver. At the transmitter, okay, so generally the message signal, the frequency is around 5 kilohertz. Maximum frequency is 5 kilohertz only. And in the transmitter, we will have a carrier signal. And the carrier signal is high frequency signal. High frequency carrier signal will be present in the transmitter. And this message signal is low frequency signal. If 5 kilohertz is low frequency, high frequency means 100 kilohertz, 10,000 kilohertz, like that. In kilohertz, very big number will be the frequency of carrier signal, because it is high frequency signal. So both of this will be multiplied, and that process is called modulation. In the transmitter, there occurs a process called modulation. Okay. In the receiver, another process take place which is called demodulation. In the transmitter, modulation occurs. At the receiver, demodulation occurs. Okay, why we are doing all this? The message signal which is low frequency, it is to be transmitted for a long distance. Okay, so low frequency message signal we are going to transmit. We are going to transmit, and it will go travel for a longer distance. It will travel for a longer distance. Okay, so generally we know velocity of light is nothing but c is nothing but f lambda, frequency into wavelength of the signal. Okay, so light signal, velocity of light signal c, you know it, 3 into 10 power 8 meters per second. The light which travels, the visible light what we are able to see, the speed of the light is nothing but 3 into 10 power 8 meters per second, and the light velocity c is nothing but f into lambda. F is frequency and lambda is wavelength. F is frequency of the signal and lambda is wavelength of the signal. Okay, and also this wavelength is nothing but 4 times length of the antenna. 4 times length of the antenna, or length of the antenna is lambda by 4. Length of the antenna, L is nothing but length of antenna. We are going to transmit a low frequency signal. We need antenna for transmission. We need antenna for transmission. We are going to transmit the low frequency message signal. We are going to transmit the low frequency message signal. For transmitting, we need antenna, and the length of antenna is nothing but lambda by 4. Lambda is the wavelength of signal which we are going to transmit. This is the general relation. Okay, I'm going with the general signal. Lambda is general signal transmission wavelength. Okay, lambda by 4. So now if you see, if lambda increases, length of the antenna also increases. Lambda wavelength increases, then length of the antenna also increases. Okay, we are going to transmit a low frequency signal for a longer distance, very high distance. Okay, and if the lambda increases, wavelength increases means this longer distance wavelength increases, so antenna height also increases. We cannot design an antenna kilometers and kilometers long, 25 kilometer, 30 kilometer antenna we cannot design. Okay, so in that particular case, what we will do, we will convert the message signal. We will convert the low frequency message signal into a high frequency signal. Low frequency message signal to a high frequency signal. And this conversion process is called modulation. This conversion process is called modulation. Okay. Okay, for transmitting low frequency signal for a long distance, we will convert the low frequency signal to a high frequency signal, and that conversion process is called modulation. Okay, now what are the need for modulation? What are the need for modulation? First one just now we discussed. Okay, C equal to F lambda, and then L equal to lambda by 4. As length, as lambda increases, length of the antenna increases. Lambda increases, length of the antenna increases. So in order to avoid this, we want modulation technique. Okay, to decrease L, message signal, I am putting M of t, frequency, low frequency is converted to high frequency. Low frequency is converted to high frequency. Okay, so message signal I am representing with a symbol M of t. Message signal I am representing with a symbol M of t. Okay, this is the first requirement for modulation. This is the first requirement for modulation. Second requirement is multiplexing. Multiplexing. In lab session also I was telling you, in digital electronics you studied multiplexer where many signals are combined. Multiplexing means mixing. Multiplexing means mixing or combining many signals and transmitting through a single path. Transmitting through a single path. Okay. So what happens when we combine many signals? What happens when we combine many signals and transmit through a single channel? Transmit through a single channel, interference will reduce. Okay, it will reduce the interference. Multiplexing will reduce the interference. Okay, randomly if they are moving, 10 signals are moving here and there without using a single channel, there will be collide of one signal on the other and there may be loss of information. which can be avoided by properly multiplexing and sending through a single channel. Okay, multiplying many signals or mixing many signals. There will be some condition when you are sending through a single channel. They will be allotted time slots, or they will be given frequency slots, or they will be given coding slots. There are different methods. Simply we cannot combine them and send it. There is some rule, time based on time. First channel can take 10 minutes time for transmission. Second channel, the second signal can take another 10 minutes for getting transmission. Third signal can take another 10 minutes. Like that, slowly, time basis or frequency basis or coding basis, we will send them into a single channel. That is called multiplexing. By following that, interference can be reduced. Okay, overlap of one signal on the other can be reduced, rather than they are freely moving in different okay, open, without a single channel. If they are freely moving, there may be chance of interference. This is the second need. Third need is narrow banding. Third need for modulation is narrow banding technique. Narrow banding technique. Okay. So what is narrow banding? What is narrow banding? So I have a signal. Let us assume I have one signal. Okay. I have a channel. I have a channel. Now I have only one channel. I have only one channel. Okay. And one signal. If the signal bandwidth is infinity, if the signal bandwidth is infinity, bandwidth means the width required for transmission of the signal. We will assume in simple words that is the width required for transmission of the signal. If it is infinity for the signal, okay, bandwidth is infinity for the signal, only one signal can be transmitted through the channel. Only one signal can be transmitted through the channel. For example, if I cut short the signal, bandwidth, if I make it finite, okay, instead of infinity, band limit the signal, band limit the signal, then bandwidth will be finite value. Bandwidth will be finite value. Okay, then we can transmit other signals also if space is there in the channel. Okay, so if bandwidth is infinity, only one signal can be transmitted in the channel. If bandwidth is infinity, only one signal can be transmitted through the channel. Okay, but bandwidth is finite, then many signals can be transmitted, many signals can be transmitted through the channel. Okay, tx, this is tx ed, transmitted through the channel if there is space, if there is space availability. Okay, also there is a condition, that also there is a condition, bandwidth of signal should be less than bandwidth of channel. Bandwidth of signal should be less than bandwidth of channel. Okay, if there is a narrow path, if I am very fat, how I will go into that? Okay, so if I am signal, if the path is the channel, if I am very fat and the path is very narrow, how I will go into that? So the signal itself should have less bandwidth compared to the channel. Only then I can try. I should try. Okay. Only if the width of the path is broader than um, my fatness. Okay. Only then I should try to move through the channel. And that is the, you can remember this easily. Channel is the thing where signal will get transmitted. So signal bandwidth should be less than the channel bandwidth always. Signal bandwidth should be less than the channel bandwidth always. Okay, so this is called narrow banding. Narrow banding means we are band limiting the signal so that there is space for other signals also to be transmitted through the same channel. Otherwise, only one signal, one channel. Now, what is the use? Okay, always the channel is allotted for one signal. Then there will be difficulty. For example, if you see FM radio stations, there is something called ISI, International Standards. Okay, international standards. They will allot some frequency band for India, and in that some frequency band for Andhra, some frequency band for Tamil Nadu, some frequency band for Kerala, Maharashtra, Karnataka, like that. Some frequency bands are allotted. Okay, for example, if I take 200 kilohertz is the frequency allotted. 200 kilohertz is the total frequency allotted. Okay, now FM radios, what they will do? Every channel they will give 20 kilohertz. Every channel they will give 20 kilohertz. Okay, I don't remember the channel names. I think 101.1